Hello everyone. So today let's solve the problem number 200, number of islands, right? So let's see what the question states here. So we are given an m into n grid. You can just look at here. You can just see, right? So here this is nothing but 4 into 5 grid. Yeah, 1, 2, 3, 4, 5. Yeah, 4 into 5 grid actually. So we are given m into n 2D grid of characters 1 and 0 respectively. 1 indicates that it is land and this one, what do we call? 0 indicates that it is water, right? So this one indicates that it is land and 0 indicates that it is water. So we have been given or we are given actually this one m into n 2D grid of characters. 1 means land and 0 means water here. All we have to do is we have to return the number of islands. We have to return the number of islands. An island is a group of horizontally or vertically adjacent ones actually. Yeah, horizontally or horizontally or vertical. Uh, this one vertically adjacent ones we have to uh, this one return actually. We have to return the number of islands. Sorry, number of islands. An island is a group of horizontally or vertically adjacent ones. All grid edges are surrounded by the water. They are surrounded by the water they have given, and we have to count each connected land component exactly once. And we have to count each connected land component exactly once, right? So see here, this part we can consider. So we can just start from here, this part. Mm, so or we can just start from here. See this one. We can either go here, this one, this one, this one. Yep. So we can come here. So then we can just go from this side, and this one, and this one. So overall, this part started from here. So this will be one actually. So this adjacent, this one we have to consider, right? Adjacent ones we have to consider, right? So starting from here, I then we can move up or down. So this one, so this one as a whole it will be one. Yeah. So this is fine. So we let's do one thing. Basically same goes with the example 2 as well. So this one is one, we can consider. We cannot go diagonal, either we can go left, right, up or down. That's what they have mentioned in the question. So this is one group. So next to it one we have, and this single one forms another group. So total it is three, right? So number of islands are three. So this one here we have the adjacent one. We can just this one consider up, down, left or right, right? Up, so then left, 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 so we'll be considering. Then when we come here, so this one will be this one down, right, followed by down and left. So this has a whole one. This one forms a island. Actually there is only one. Yeah, number of islands, this one equals one. Here in this case it is three. Yeah, so let me delete this one. Yeah, so this is fine. Now before hopping into the approach, let me tell you one thing. So we will be solving this one with the help of BFS, right? So we can easily solve this one with the help of BFS. So let's do one thing. Let's solve this one with the help of BFS. So let me consider the same first example for the approach as well, right? So here, just listen to me carefully, man, here, right? So first step would be, we will be scanning the grid row by row. We will be scanning the grid row by row, right? So until we have found the one at the first one, right? So the top left, we have found this one. First, we will scan the first row. So this is row 0. So this is row 1. This is row 2. And this is row 3. Yeah. So in the first row, or nothing but the R0 here, so we have found the one at the top list, the first cell itself, in the first cell itself. So we have found the one at top left. So we discover a new island, increment count to 1, right? Increment count to 1. Then what we will do, we'll start a BFS from that particular cell. We'll start the BFS from this particular cell itself. Yeah. So we'll treat the grid as a graph. Each one is a node with up to 4 neighbors, right? So we will mark the this one, every visited one, as 0. So every visited one, whatever we have this one visited, so we'll mark this one as 0. First we will go with 0. Next, right, we have 0. This one also we have 0 up the right, because we have 1 here. So next we will visit 1, so this is also 0, and 0 remains 0 itself. So this one, last one. So then what we will do, we will be expanding the BFS, right, to all the connected ones, right, down, left, and up. So in the BFS, so here row by row we are going. So first we have completely this one, what do we call, found all the ones, and we have connected this one to the 0. So at one step we can move down, left, or this one, right or up, right? So up we don't have anything, down we have one. So now we will come to the second row. Now again we have found one here attached, right? So this one we will this one change to 0. Again we can move one step right, left, down or up. So here in this case in right we have again found 0 here in this particular row, right? So this one will connect 0 and this one remains 0 and this one it is not connected here in this case. So this is connected to this particular one, this row, this one we have connected, right? So from this one only one step it takes, and this one again we are converting this one to the 0 and 0. So this is fine. This is for the second row, nothing but the R1 here. These two are completed. Again we'll check for everyone in the same way, right? So for the this one we have one, for one we have 0. Yeah. So again next to we can check right, left, up or down, right? So we'll be going right. So again we will be this one going with one. Will we have one at the right, we will go to this cell and we will this one mark this one as 0 after visiting this one. So other zeros remain same here, right? So finally we have all zeros, we don't have one at all here. We will change this one to this one 0 itself. So at one shot we got this one only one island after this one after visiting. So we have marked this one as all zeros. We have done this one only exactly once. So at one shot we got one, so we will return this one as the output basically. So BFS expands to all connected ones here, right, down, left, up, and marks them visited after the this one after BFS finishes, right? So the whole connected component, the island is cleared here in this case. So we will continue scanning the grid. Any later one would start a new BFS and increment the island count. So in our case, we don't have, everything is connected here. Everyone is connected to other one. Here in this case we will go with this one. Okay, we got here. Then this row, this one, it is connected down, so we'll start from this row, right? So this is fine. Next, we don't have anyone that is connected here. Diagonally it is connected, but we cannot consider diagonal, right? So when we come this row, this one will be entire this thing. This is one group and this one becomes one group. Again, this is connected diagonally, not this one left, right, down or up, right? So we have to check this row. We have already checked this row as we are making use of the BFS actually. We don't have to worry about this first two, and we have to check this row now. Yep. This one, third and the fourth row. So third row, it is not, so left one is not found, right one is not found, and down we have 0, right? Diagonal we cannot consider accordingly with the question. So this forms one group. And finally at when we are going with this one 0 1 2 3 third row, or the fourth row if we are considering one best here. So this one, the last row, so here we will find one, and right to it one more one is found. So this is one island. So total overall 3. So this will be quite obviously 0. Will be carrying on this one BFS until we have converted this one all to zeros actually after visiting all the ones. Yeah. So this is fine. So for this one we got 1, and for this one we have got 3. Simple ones. Yeah. Very simple ones. So let me delete this one. So now we have complete idea on the approach. So what we'll be doing. Yep. So here in this case, the result that we got here is 1, which is equivalent to the output that they have mentioned for the example 1 within the question. Yep. So now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part 1. So what will be the time complexity here? The time complexity would lead to big of m into n. So the time complexity would lead to big of m into n. Yeah. So why it is big of m into n here, the time complexity? So every cell is visited at most once, and each neighbor check is big of 1 here, right? So overall time complexity would lead to big of m into n. So what would be the space complexity? It would be big of min of m into n, and also the perimeter of the BFS frontier. So this is almost equivalent to big of m into n itself. So let's, in simple terms, let's consider this one as big of m into n itself. Yeah. So in the worst case for the Q, right? So this is fine, man. The space complexity would lead to big of m into n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the, yeah. So this is fine. So now first step here would be, so if the grid is empty or null, if the entire grid, we don't have any land or this one water, if the grid is empty or null, then there are no islands at all. In that case, we have to return 0, right? So first let's go with the base case here. So if grid equals null or length of the grid, if it is equal to 0, then let's return 0. This is fine. The next step would be, let's go with the number of rows, number of columns, as well as the result counter. I mean, let's initialize m, nothing but the number of rows, n to the this one, nothing but the number of columns, and result counter. For the result counter, let's consider the islands variable. Yeah. So let me initialize m to the let me go with length of the grid. So let me copy this one entirely, and so this is fine. Let me initialize n to the columns actually. So this one, let me grid of 0. So this is fine. Next, let's consider the variable island. So this is fine. Let me initialize this one to 0. Nothing but the last one is result counter, right? So now we have the directional vectors for up, down, left, and right. Nothing but the graph edges. Let's write that one or articulate that one in the form of code. So this one will be int dr, nothing but it's related to the row. So this one will be -1, +1, 0, as well as the 0 for all the directions. Yeah. So this is fine. Uh, this one will be DC for the column. So this one we have to start with 0. We know this one. We have solved. We are almost at the end of this one graph topic. At the this one, we are solving the Codeforces problem as well, right? So we have already solved 47 problems, man. We are left with only three problems actually. I said we'll be solving the 50 problems on the graph. We have covered almost all the topic actually. At this point of time, we have to know most of the topics, right? So the number of codes that we'll be writing in the lead code will be this one. The number of this one lines, the code length will be less compared to the this one Codeforces, and we have covered almost all the topics. We have to know these kind of things, right? So let's write this one very quickly, man. So this one will be -1, 1 respectively. Yeah. So this is nothing but the row changes and the column changes. Now let's do one thing. Let's iterate over every cell in the grid. Yep. So we are making use of the BFS, right? First thing, before that, let's iterate over every cell in the grid. So let's go with the two for loops here. So this one will be int I equals 0, I less than m, and I plus plus. So this is fine. Let me go with one more for loop. So this one will be int j equals 0, j less than n, sorry, j plus plus. So within the for loop, what we'll be doing first, when we find the land or when we find the one in the grid, right? It's a new island, meaning the unvisited one I'm speaking of, right? So we have to increment the this one, basically island count, right? So in our case, we have considered this one island variable here, islands, right? So this one, let me write the simple if condition. So this one will be grid of I j if it is equivalent to this one within the strings 1, then what we need to do, we have to increment the island. So islands count actually. Let me give here islands plus plus. So this is fine. Yep. The next part would be um, we have to mark the particular cell by turning it into the 0. See, after visiting the land actually, after visiting this one, we have to mark this one. We have to mark this one as visited by turning this one into the 0 actually. So now when we have found the land, so we will be incrementing the island count along with the this one, marking that one as the 0. So let me give here grid of I j. So this one is equal to 0. This is fine. Yep. Now let's make use of the this one dq as this one as a queue for the BFS, right? So we are going with the, or I said we'll be going with the BFS, right? So we'll be making use of the BFS now for the graph traversal. So I'll just go with here dq. Let me make use of the int. So this is fine. Yep. So let me go with the q equals new. Sorry, I'll just go with the array dq. So this is fine. Let me complete the syntax here. So this is fine, man. Yep. Now let's enqueue the starting cell. So this one will be q dot add last. So this is fine. New int of mm, this one, I comma j, I comma j. So we are just enqueuing the starting cell. So this is fine, man. Now let's do one thing. Let's go with the BFS to visit all the connected land cell for this island. So let's go with a standardized BFS loop here. So this one, let's make use of the is empty operation. So within the while loop, so let's do one thing. Let's dequeue the current cell. Also, let's consider the current row as well as the current column. These three things first. So this one will be current equals q dot removal. So we can just go with a poll as well, right? So I'll just go with the remove first itself. This is fine. I'll just go with the r equals current of 0. This is fine. Also, we have to consider the current column as well. So this one will be C equals current of 1. Yep. So this is fine. Now let's explore the four directional neighbors, right? So let's consider here one more variable named k here. So this is fine. K equals 0. Four directions we have. So 0 to 3. This one has to be k less than 4. And also let me increment the k here. So within BFS uses so we are going with the iterative BFS, right? So BFS uses iteration. So let's go with the neighbor row as well as the neighbor column. So this one will be int nr equals r plus dr of k. So this is fine. And also let me go with int nc equals C plus DC, this one of K. This is fine. Yep. Now let's do one thing. Let's check the bounds and if the neighbor is unvisited, if the neighbor is unvisited land 1, right? So let me write the last if condition here. So this one, let's check the bounds first. If nr is greater than or equal to 0 and n r, if it is uh, greater than the rows, actually m, and nc, if it is greater than or equal to 0 and nc is less than if it is less than n actually, and we have to include here grid of so we have considered nr and nc, right? Sorry, I'm confused. Nr and nc, if it is equivalent to the land, then what we have to do here, so we have to mark the neighbor visited. So this one grid of nr and C, this one, let's set this one to the 0. This is fine. Finally, we have to enqueue the neighbor. So I'll just go with q dot add last here. Let me go with new last here. Sorry, I have to go with the new int, right? So I made use of the add last. I got confused here. So this is fine, man. So finally, what we have to do, let me pass here nr and nc, nr and nc. So this is fine. Yep, we are just enqueuing the neighbor, right? So let me come out of this one entirely. This is fine. So should I give anything here? So I don't have to give anything here, I believe. I think so. So let me give here one thing. So we have to return the total number of islands that we have found. So I'll just give here return islands actually. So this is fine. So this is it for the code. Let me format the code one so that this looks nice, man. Yeah, now this looks nice. This is fine. Yeah, let me hit the run button. I hope this works. Let's see. This has to work. Let's see. We have some error here. Add last L has to be capital. Line number 32. Yeah, this is fine. Hit the run button. Array DQD has to be capital. Line number 18. So now the sample test cases are getting passed. So let me hit the submit button quickly, man. I hope this works for all the test cases. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases. Yeah, this is very simple one, man. Yeah, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.